So to think about distance and midpoint formulas, we need to start thinking about a few old concepts. So one, we need to remember our x and our y axis, right? Okay, since we're talking about the distance and midpoint between spaces on a line. Now, let's also remember the Pythagorean theorem, which we just learned, which Pythagorean theorem stated that a squared plus b squared equals c squared. Okay, if you keep those things in mind, we can move on. So if we look right here, we have this line, and we have 2 points, our endpoints for that line. Now, if I were to ask you what's the distance of this line, you would say, I'm not quite sure what I need to do. So I'd say, okay, since it's on a grid, as you can see by this grid back here, I can connect and make this into a triangle. And since I did this right here, I made a right angle, so I have a right triangle. So this is why I said, remember what we know and what we learned about the, what was it called? Pythagorean theorem, right? So remembering that, we can do something with this using this as a triangle now. Now, remember to label our parts of our triangle. We know that we have 2 legs and a hypotenuse. We know that the hypotenuse is that side opposite from our what? From the right angle. So there's our C, which is our hypotenuse. We also have our legs. So we have leg A and leg B. Okay, now it should look like a triangle where we remember what we learned from Pythagorean theorem. So let's write it out. We have a squared plus b squared equals c squared. Now you're going to say is, well, I don't know what the length of each of those is. Like I don't know what a is, I don't know what b is, and I don't know what c is. You're right. But we can figure that out though. Let's look at a. We can say that it starts here and it ends here. That would be a change on our x or our y axis. That is a change on our x-axis, correct? So if you look at it, we went from 2 to 7. So what is the difference between 7 and 2? That's like saying 7 minus 2, correct? That is our distance for A, isn't it? Think about it again. 7 over here minus 2 is our distance right here, because here's 7, here's 2, there's our distance, okay? So we have 7 minus 2, which is our distance there, and we are going to say that that's squared, plus, now, look at B. Can we do the same thing again? Can I say that the difference from here to here, is that a change in the x or the y-axis? Well, my x stayed the same, they're both 7s, right? But my y did change from 1 to 3, so I do have a change here. That change would be the distance, wouldn't it? So this distance was what? I'll put this little arrow right there so you know what I'm talking about. This changed from 1 to 3. So that difference between 1 and 3, we'd say is 3 minus 1. That'll tell us the difference between the two, correct? Now C is what also we're trying to figure out. And so C, let's see, we had a change there, but we had 2 numbers change. We had our x and our y change. So we don't know what our x and our y, we don't know what that is. That's what we're trying to find out. So we're going to leave that as just C for now, C squared. And over here to the side, I'm going to make a little note that C is really AB, right? Because what I'm saying here is that for A, in this distance right here, A is AC, correct? And B is BC. Like if I'm talking about lines is what I'm talking about here when I say A is AC. So the line is segment AC, and we have piece right here is segment BC, and this segment is AB. Correct? Okay, those are our lines. Okay, moving on. Now, can I do something with this? I look right here, 7 minus 2. What is 7 minus 2? You should be by now able to tell me that's 5. Now, don't forget our little squared sign and leave it as 5 squared. Now we're going to say 3 minus 1. Well, 3 minus 1, I really hope you could tell me, which is what? 2, and then again, don't forget our squared sign, so we have 2 squared. Then we're going to say still equals c squared, which understanding is AB, is the line segment. That's what is C. Okay. Now, let's take this to the next step. 5 squared is 25 plus 2 squared is 2 times 2. It's not 3. 4. Okay, cool. Okay, now I've got 25 plus 4 equals my c squared. Okay, moving on. 25 plus 4, I'm going to move up here. 25 plus 4, we should be able to tell me is 29. That equals c squared. Now remember what we learned about the Pythagorean theorem. 29 does not mean that is the length right here. 29 is not our side. What 29 is our c squared. So we need to still find the square root. And we'd say the square root of 29 to the nearest tenth, I'll say, is about 5.4. And that is our c. That means that this length right here is 5.4 units. So here's everything we just did on the last page. Now I'm going to take it a little bit further. Look at our point A. Point A is at the point 2, 1. That 2 is our first x value, correct? So that's x1. That's our first x value. B is at the point 7, 3. 7 is our what? That's our x value again. That's our second x value, right? So it's x2. Now, at the point A, 2, 1, 1 was our what? 1 is our y value, and that's our first y value. 3 is our second y value, correct? So if I were to say to you, what is x1? You'd tell me that's the first x value, which is a. If I was to say, what is y2? You'd tell me that's the second y value, which is y2. So we have x1, y1, x2, and y2. Okay, what did we do to find those distances right there? Now, if you think about it, what we did do, we said this value minus this value. We also did this value minus this value. That's how we got A and B. Didn't we talk about A here and B here? When I mean A and B, I mean side A, side B, and side C. When I talk about side A, I did the difference between the x values, right? I did this one minus this one gave me this length right here. For side B, I did this length minus this, this spot versus this spot, and I subtracted them. That gave me this length right here. So if you think about it, what I said was x2 minus x1, right? That's right there. That's saying this value minus this value, which is my A, correct? Okay. Now I'm saying keep that together. Plus, I also said that y2 minus y1, which y2 minus y1, that's this value minus this value, was our what? That's my b, correct, right there. Now, I went ahead, I squared them, right? Put a little squared there. And I said that all of that equals what? I said all of that equals this length right here, which was a b, correct? Okay, so this is starting to look like, is it starting to look like the Pythagorean theorem where like something squared plus something squared equals something squared? Okay, that means that that value equals this one, so like c squared. Okay, that c in this case is our distance, right? Our distance. So let me rewrite this now as a distance formula. If I were to say that the distance is equal to, now think about when you do this. Once you've got these values on the right here, and you've got this, you had to find the square root of everything in order to get it by itself. So what I mean by that is I would put a big square root sign over the whole thing. This would give me c by itself, and this value, right? I would find out what c is. So I'm going to go ahead and put that into this next equation right here. So my distance is equal to the square root, right? So far, it's still like that one above it, of x2 minus x1 squared plus y2 minus y1 squared. Again, if you look at it, it's still kind of like the Pythagorean theorem. So if you're given a set of points, and here's the distance formula, we're going to apply it. If you're given these points right here, A and B, and they are on a graph, okay, we have our x value, we have our first x value and our second x value. We have our first y value and our second y value, correct? So we have x1, x2, y1, y2. I can take and plug those in, substitute them in the distance formula. Like here's x2, here is x1, here is x2, here is y1, here is y2. So let me go ahead and put those in. I would say that x2, which is, in this case, 1, minus x1, which is 6 squared, plus. Now do y2, which is 9, minus y1, which is 3 squared. Find the square root of the whole thing, and that's going to be the distance between those two, isn't it? Okay, so let's start simplifying this. D equals, okay, right here, 1 minus 6 is what? Negative 5 squared plus 9 minus 3 is what? 6 squared, okay? Next line, now, sorry, put that there, D equals, what is the square of negative 25? I'm sorry, of negative 5. Negative 5 times negative 5 is 25, plus 6 times 6 is 36. Okay, next line, 25 plus 36. So we say D equals the square root of, what is 25 plus 36? 61. Now, if you remember what we learned about with finding the approximate value, so we know this is in between what two squares? Well, 7 times 7, so 7 squared is 49. 8 times 8, or 8 squared, is 64, right? So it's in between those two, and it's much closer to 8. So we'd say it's past 7.5, but not 8. So if we start doing it to the nearest tenth, we'd actually find that the square root of 61, or our distance, is about 7.8. So I'll make that about, a little squiggly. So it's about 7.8, all right?